We can stop HIV, Iowa. Everyone has a role to play in stopping HIV. Unfortunately, there are barriers that make our job a little more difficult.
Stigma is one of our biggest challenges. According to a survey, 27% of respondents who were living with HIV said they waited to get tested because of the stigma.
So we should talk about HIV more.
And support people living with HIV.
Find out more at stophiviowa.org.
Today's episode of Space Nuts is brought to you by Physical Attraction, a new podcast that tries to explain physics one chat-up line at a time. Available now from wherever you get your podcasts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on the astronomy podcast that we like to call Space Nuts. We were going to call it something else, but that was taken, which was Space as We Know It by Intelligent People. We got Space Nuts. But that's okay.
It's better than Space Ache.
Yes, exactly right. And joining me as always, I'm Andrew Dunkley, by the way, your host, and Fred Watson from the Australian Astronomical Observatory.
Good day, Andrew.
You didn't see the queue. You came in too early.
I'm sorry. I was too enthusiastic.
Oh, that's okay.
I just can't wait to talk to you. That's what it is. So.
We like that. We like that very much. Now, today we're talking about a video that's been released by NASA, which you can look at on the interwebs, of a flight over Pluto. It's only a couple of minutes, but it's well worth looking at. Gigantic jets over Hawaii. We're not talking Dreamliners or A380s. We're talking actual jets out of cloudy things, which is their official name. And giant lava blobs that created Iceland and Hawaii. So Hawaii is sort of in the headlines on both of our, or two of our stories today. But first, let's talk about this NASA video, the flight over Pluto, which I've just had a look at, and it's a nice sort of slow motion representation of just coming over from the dark side to the light of Pluto. It's very, very clever and fascinating too.
Beautifully done. And it underlines the new knowledge that we've gained about Pluto since the New Horizons flyby, which this is basically an animation made from the data that came from New Horizons. Since that took place on Bastille Day in 2015, July the 14th, 2015. That extraordinary mission, I think, ranks among the great scientific enterprises and was basically done on a shoestring budget. And I had the great good fortune today, in fact, to meet two of the scientists involved with it, including the principal scientist and the brains behind New Horizon, Dr. Alan Stern, of the Southwest Institute in Boulder, Colorado. Extraordinary stuff to see him telling the story of New Horizons and Pluto. It's a story that's been well told, and certainly I've lived and breathed all that stuff for about the last decade. But to hear it from the man himself was quite impressive. And he showed many of the images that we've become familiar with of this really amazing dynamic world. Everybody expected Pluto would be a pockmarked, dead world that really had nothing going on there, just leftover craters from bombardment when the solar system was in its infancy. But what we found was surfaces that are very, very youthful, certainly less than 100 million years old, probably in some cases less than 10 million years old, which as in geological time is really just yesterday. The one piece of information that fascinated me, Andrew, was a picture that I hadn't seen before of Pluto's large moon, Charon. And Charon is a world that is actually half the size of Pluto. It's a large object, comparable with the planet itself, or the dwarf planet itself. It's so big that it actually pulls the mutual center of gravity outside the body of Pluto. And so Pluto and its moon Charon actually spin around a point that is just an empty point in space. It's called the barycenter, or the center of mass, and that defines them as being a binary planet rather than a planet or a dwarf planet and its moon. Charon, though, is quite different from Pluto. It is more heavily cratered. It's a different color. It's pretty uniform all the way round. Uniformly grey was how Alan Stern described it. But what surprised me, and which I hadn't seen before, was a kind of crack around its equator. And it's not just a single crack, it's a system of canyons, of chasms, that basically run around the equator of Charon. And it struck me as being something similar to a phenomenon that we see on one of Saturn's moons, Iapetus. But what Iapetus has around its middle is not a crack or a depression or a series of canyons. It's got a ridge, that's right, a mountain ridge. But it turns out that they probably have something in common, because we know that Iapetus's mountain ridge came about because essentially as Iapetus cooled from its molten state early in the solar system, as it cooled, it contracted, and it meant its crust was a bit too big for the size of it. So exactly, it buckled up into a ridge around
hand
the equator.
gestures, just
yes,
in case
hand
you're
gestures. I'm sure your listeners saw them. I certainly did. Whereas here's the tricky bit. I thought this was really neat. Charon has a large fraction of its material being water ice. So it's like so much in the outer solar system, it's made largely of water. And of course, water, as it cools, expands. When it freezes, it actually gets bigger. And so what it's done is split Charon open. Rather than formed a ridge, as has happened with the Iapetus, it split open Charon to reveal this kind of set of canyons and chasms all the way around its equator. Remarkable stuff. Charon is rather more than 1,000 kilometers in diameter. As I said, half the diameter of Pluto. A very interesting and important world. One other comment while we're talking about Charon is that it's also got polar caps. Well, it's got one polar cap. We couldn't see the south side of it when New Horizons flew by. We could only see the North Pole region. And that polar cap is, unlike the rest of the planet, of the satellite, the moon of Pluto, it's which is grey. Okay, so Charon is mostly grey, but it's got a brown pole. The polar cap is brown, and the basically the thinking behind it is that what you're seeing here is the effect of hydrocarbons from the atmosphere of Pluto itself. So this is gas from Pluto's atmosphere being transferred to Charon itself, where it condenses out on the surface. And because of the effect of ultraviolet light from the sun, is modified. And it's modified to produce chemicals called tholins. And tholins are exactly the same brown colour as we see at the pole of Charon. And that is the thinking behind what's happened there. These are all processes that are fairly well understood physical processes, but of course are happening at temperatures which are way, way below anything we experience in the inner solar system. If I remember rightly, it's colder than minus 200 Celsius. I think 220 or thereabouts comes to mind for the surface temperature on Pluto and Charon. And so the physics there and the chemistry are quite different from the things that we're used to here on our own planet. Amazing stuff.
Yeah. So, given the discovery of the water ice and the swapping of atmospheres and the crack along the equator in Charon, basically what you're telling us is Pluto is giving Charon a universal wedgie.
At least something of that kind. Yes, it's a wedgie and a half actually, given that it's 1,000 kilometers multiplied by pi. Yeah, it's good stuff.
Nasty. All right. And of course, if you want to see the New Horizons flyover of Pluto, just jump online and do a search for it, because it is well worth looking at. It's very impressive. I suppose you call it footage, but a collection of images, I would imagine, that have been put together to create this this amazing flyover. I think you do a full lap of the planet, if I'm right.
More or less, yeah.
Yeah. All right. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson.
3, 2, 1.
Space Nuts.
Now we're going to talk about something closer to Earth, and Hawaii will be in this topic and in the next topic for a completely different reason. But we're going to look at gigantic jets over Hawaii. Now we know it's a very popular tourist destination and there are big jets flying in and out of Hawaii all the time. That is not what we're talking about. We're talking about atmospheric jets, I suppose, for want of a better term. But that's why Fred's here, because he's going to explain it. I'm just having a snowball's guess. So what sort of jets are we talking about here, Fred?
Yeah, exactly. Space jets, in fact, and natural ones, not anything created by humans. Why do we know about these things? Well, because Hawaii is home to the big island of Hawaii, which is home to the Mauna Kea volcano, or dormant volcano, which is home to the Mauna Kea Observatory, which has some of the biggest telescopes in the world. And so they are equipped with very sensitive cloud cameras. One of them, the Gemini telescope, which is called Gemini because it's got a twin in the southern hemisphere in Chile. The Gemini cloud camera records approaching storms and all the rest of it all the time, 24/7. Well, I'm sure it's perhaps only at night. But what they have often recorded with the Gemini Cloud Cam is a phenomenon that's called sprites. And sprites were first discovered in the late 1980s. And these are like upward pointing lightning strokes from clouds. So if you've got a cloud that's a thundercloud and it's discharging lightning to the ground, in the form of conventional lighting, the stuff that we're all familiar with. We now know, and it's been known since the late 1980s, that there are often upward pointing strikes as well, coming from the top of the cloud. They're often red, and they're called sprites. That's the name that was given to them. They are relatively common. They've been observed many, many times. You can often find photographs of them on websites that concentrate on the sky at night, and there are many websites like that. But what the Gemini cloud camera observed recently, this was actually, as we're recording this now, it was just a week or so ago, was something that has a different name. It's called a gigantic jet. And it's like a sprite, but it's gigantic. So this is a bright flash that extends upwards from the top of a thundercloud and goes right up to the ionosphere, something like 80 kilometers above ground. So, you know, the thunderclouds themselves might stretch up to 15 or perhaps 20 kilometers. But these, and sprites are not much further than that when you get sprites occurring there at lower levels. But this gigantic jet that was captured and others that have been observed, they've only been observed since 2002 or so, they actually are much more spectacular. So a very nice image, once again on the Space Weather website, worth a look, an image of the gigantic jet over the mountain of Mauna Kea in Hawaii.
Have they figured out what causes these things?
There's certainly a lot of work been done on it since they were discovered. I suspect the gigantic jets themselves are not really all that well understood. The sprites and some similar phenomena or related phenomena, some of which go by the name elves. There are elves and there's all sorts of other slightly odd-shaped things that seem to be associated with these relatively low-level discharges coming from the top of thunderclouds. I think the physics of those is pretty well understood. And if I remember rightly, it means you have to have a cloud that is positively charged rather than negatively charged. And you can have either, but it's only the positively charged ones that release the sprites. Now, whether that is true of the gigantic jets, I don't know. And I'm not sure how much research has been done on this because there is really, they're rare. There are not many photographs of them. And even smaller amounts of other kinds of observations. So I think this is one that we'll hear more about as time goes on, but they are very spectacular. The one that's on the Space Weather website is really extraordinary.
Oh, it's amazing, but it also suggests that's a massive amount of energy being discharged.
That's right, indeed. And where's it going? Out into space.
Yeah.
It's probably some sort of interaction with the solar wind as well, Andrew. You know, this wind of charged particles that comes in from the sun. Almost certainly some kind of influence from that too.
Fascinating. And yeah, great pictures, great photos. Have a look at them. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson.
Space Nuts.
Let's take a break now and hear a word from our sponsor, the new podcast, Physical Attraction.
Look into his eyes. They're the eyes of a man obsessed by sex.
Disturbed? Concerned?
A man whose
Maybe a little bit
desires and limited
intrigued?
practices are used to
Physical Attraction is a new podcast where your host will attempt to explain concepts in physics, one chat-up line at a time. Find us on iTunes or wherever you get your podcasts, and on Twitter, @PhysicsPod. See you soon.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Last but not least, Fred, and still focused on Hawaii, but we bring Iceland into this particular equation as well. And they've recently announced that the reason these two places exist is because of giant blobs.
It's the technical term.
I'm sure it is.
It's described as a reservoir of partially molten rock, described by scientists as a blob.
Oh, there you are.
So this work really, I mean, we're kind of segueing loosely from our discussion about Hawaii, because Hawaii, the Hawaiian chain of islands has been formed, and indeed are still being formed actually, by the fact that there's a hot spot underneath the Earth's crust there. And that hot spot pokes through and actually it reveals itself by volcanic eruptions from the seabed, which eventually poke mountains up higher than the seabed, and they're still being built as we speak. The volcanic activity on the big island of Hawaii is very spectacular. So that turns out to be essentially the result of one of these blobs. But the research that we're describing actually relates particularly to Iceland. And indeed a phenomenon or an entity that goes underneath the surface of the Earth, which is called the Iceland plume. And it's a plume of upwelling molten rock that over the last few million years has created Iceland itself. Now, Iceland, of course, sits on the mid-Atlantic ridge. It's the boundary between two plates, the Eurasian plates, two tectonic plates, that is, the Eurasian plates and the North American plate, and they are drifting apart at roughly the same speed at which fingernails grow.
Wow.
As the volcanologist who comes with us to Iceland when we visit there tells us that's how fast these two halves are pulling apart.
That's
it's
actually pretty quick in the scheme of things.
It is. It's a few centimetres a year. That's right. So that's the two plates are drifting apart at that speed. But underneath that joint, there is this blob, this partially molten rock reservoir, which is something like 800 kilometres in diameter and located something like 2,800 kilometres below the ground. It's roughly 15 kilometres high, so it's like a big flat pancake that sits underneath the region where Iceland exists and basically allows the volcanic activity. It's scientists actually at the Berkeley Seismological Laboratory in California who've used something called seismic tomography. It's the same as computer tomography that we use to probe the inside of our bodies, but you can do the same sort of thing with seismographs to reveal what is underneath the surface of the Earth and deep under the surface of the Earth. And they've seen these features, which are basically areas of the boundary between the core of the Earth and its mantle, and that's way, way down in the depths of the Earth, that it turns out that seismic waves from earthquakes go through this area about 30% more slowly than around the neighbouring area. That's how you know this thing's there. And they are quite rare. They're very deep, but they seem to be the cause of these blobs, the partially molten blobs that give rise to places like Iceland and almost certainly Hawaii as well. Perhaps some of the Pacific islands too. So
maybe in Indonesia, perhaps.
Yes, that's right. It could well be that we've got similar things going on to our north here in Australia. But really interesting stuff. And is it to do with space? Well, the Earth is a planet. We talk about everything that concerns planets and what's happening deep under the surface. It might be inner space, but it's still part of Space Nuts and what we talk about. The volcanology of these places is very, very interesting and actually part of our understanding that leads us to basically understand how other planets in the solar system and beyond might work.
Oh, yes. I mean, my wife and I are fascinated by volcanoes, and we've visited a few on our travels and stood right on the edge of a few, as you have too, Fred.
Indeed, yes, that's right.
You don't realise the magnitude of the power of the inside of the Earth until you're standing on the rim of an active volcano and you feel and hear and smell and taste what's blowing up in your face. I mean, it is just awe-inspiring and absolutely terrifying.
Yes, it's terrifying, that's right, especially because you get these sort of burps of really quite toxic gases, very sulfurous fumes. And I was on the rim of one volcano and the guide said, just turn your back to them, they'll be all right.
That'll fix it.
That'll fix it,
Well, Mount Yasser was one we stood on. It's not a big volcano because you can walk up to the top of it and it only takes 5 minutes, but gee, it really is a busy little volcano, that one, and we saw some amazing things. And I often tell the story of when we were standing up there, the wind changed and everything started blowing towards us. And the guide said, time to get off, the lava bombs, 3,000 degrees. And as we're leaving, one of our group decided to lollygag a bit and stood and waited on the rim a bit longer. And there was this massive bang. And I had enough time to take my camera out of my pocket, turn it on, focus it, and take a photo before the lava hit the ground. And I've got her sort of standing by herself on the edge of the volcano with all this stuff raining down. It's amazing.
Was she okay?
Yeah, she was fine. It didn't land on her, but I did see video later that a friend of mine took of a lava bomb landing in front of me, and I never saw it.
Wow.
Never saw it. It was 20 metres probably from where I was standing.
There you go. You had a lucky escape, probing the inner depths of our planet.
Yes, indeed. Kilauea, I enjoyed that too. It's a completely different situation. It's it's like a very sad old Labrador compared to Mount Yasser, but in a nice way.
Labradors are nice.
Very much. All right. Thank you, Fred, as always.
And a pleasure to talk to you too. Thank you very much.
We'll see you next time. Fred Watson from the Australian Astronomical Observatory, and from me, Andrew Dunkley. Thanks as always for listening. Don't forget to write, Facebook, Twitter, whatever. We certainly love your questions, your comments, your feedback, anything you'd like to convey to us. Please do. Don't forget to listen to our sister podcast, Space Time with Stuart Gary. Until next time, goodbye.
Space Nuts. You've been listening to the Space Nuts podcast.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.
Today's episode of Space Nuts was brought to you by Physical Attraction, a new podcast that tries to explain physics, one chat-up line at a time. Subscribe at all good podcast outlets.